Welcome once again to another investment analysis video. This time I want to show you that the analysis that we presented in the last video was done in terms of dollars, but we can also do the same analysis in terms of percentage changes. In other words, we can look at our risky distribution of possible outcomes, and while we have the terminal wealth value assumptions, we can also turn those into HPRs. So if we start with 50 and we end up with 30, it's an HPR of minus 40%. If we start with 50 and end up with 40, it's an HPR of minus 20. 50 to 50 is 0. If we start with 50 and end up with 70,000, then it's a plus 40% HPR. So the analysis can be done in terms of HPRs, of course. And of course, we can multiply the 0.4 by the minus 40 and add that to the 0.3 multiplied by the minus 20, minus 0.2, of course. And then I've done that over here, and then you sum them, and you get an expected HPR of minus 18%. Okay, so again, here we see in the analysis presented in the prior video, if we were to do the analysis in terms of HPRs, we can certainly calculate an expected HPR, which would be minus 18%. And I say this to get you to think about realistically what a risky distribution of possible outcomes would look like, since we can certainly couch it in HPR terms. Well, you might want to think that, and you'd be correct, that this is kind of silly to just specify a few and act as if you know the probabilities and act as if you know the terminal wealth values, which of course we never do. But it's helpful in that it gets you to think about the distribution that might exist that describes and defines the potential outcomes from an investment, okay? And one thing to recognize is that the distribution that applies to HPRs, to holding period returns, is not a normal distribution. And it's very important to understand why it's not a normal distribution. And that is because a normal distribution is asymptotic to the horizontal axis. That means the function never actually hits the horizontal axis as it approaches negative infinity to the left or positive infinity to the right. And so that's the nature of a normal distribution. However, with HPRs, the worst performance that you can ever observe for the change in, for example, a stock's value is that its value goes to 0. We can't have negative prices, and that means that the HPR that represents the worst possible outcome is minus 100%. So if we have a normal distribution, then realistically, when we're talking about HPRs, we can't have any values to the left of minus 100%, and the normal distribution doesn't allow for that. And that's enough for this video. I'll pick up on that topic in the next video. Thanks for watching.